Good. We're on, again, page 4 in your Unit 5 notes packet for today. So last time we looked at two big ideas. What type of information, what type of responses am I getting when I ask a question? Are those responses numerical or not? If the responses I got out were a number, if they were numerical, we called that quantitative data. I was getting some sort of quantity. So if I asked you your height, that would be a quantitative response you would give me. You would give me some number, right? Presumably your height. The other type of response we looked at was categorical. So that would be really anything that's not a number. So if I asked you your hair color, that was an example we looked at yesterday, you would be giving me a categorical piece of information, categorical data, because you're not going to tell me a number when I ask you your hair color. The other thing we looked at was the difference between statistical and non-statistical questions. So the idea of a statistical question is that I would expect some variation in the answers I get depending on who I ask, okay? So an example of a statistical question that we looked at was something like, what's the average height for the class, okay? If I survey heights in each of my classes and I find the average for each class, I would expect to get slightly different results in every class. They may be close, but I wouldn't be surprised if they were different, okay? A non-statistical question would be a question I could ask where I would expect every person or every class, every group to give me the same response. So one that we looked at yesterday was if I asked you how many desks are in my classroom, I would expect every person to come up with the same number, right? You would count the desks and then tell me how many you found. That would be a non-statistical question. Moving forward in our unit, we're going to be focused on statistical questions and quantitative or numerical data, okay? That's going to be our focus as we're looking at sort of intro statistics in this unit. Today, we're going to look at how we can organize data that we collect. So I've come up with my statistical question. I've collected my quantitative data. And now I want ways to be able to organize or represent that information that I've collected. Instead of having just a big list of numbers, I want to be able to display it or represent it in a way that makes it a little easier to read. That's the big goal. We're going to look at 3 different ways that we can represent data today. We're going to talk about dot plots, we're going to talk about histograms, and we're going to talk about box plots, okay? So really quickly, we'll go into detail on each of these, but really quickly, this first graph that I see towards the top of page 4 that has all the dots in it, that's a dot plot. If it's got a bunch of dots, it's a dot plot. This graph towards the middle of the page that looks like a bar graph, and you guys had several problems working with bar graphs in your homework last night. If it looks like a bar graph, in statistics, we call it a histogram. And then the last graph we see towards the bottom of page 4 that's got this box in the middle of it, that's a box plot. With me so far? Okay. So let's talk a little bit more about what we see in each of these graphs. So each of these graphs are representing the same pieces of information. So they all are summarizing hours of battery life for 26 cell phones while streaming video. So it looks like we asked people to fully charge their phones and then stream Netflix until their phone died. Okay, that's basically what we asked. So charge your phone and then start binge watching something on Netflix or Hulu or whatever until your phone dies. And then tell us how long you were able to watch. So for our dot plot, all of these little dots represent cell phones. So every single cell phone, if I counted these all up, there would be 26 dots because I had 26 cell phones. They represent every single cell phone that we had. And specifically, they represent how long the battery lasted for each cell phone. So I've got a dot here that represents a cell phone that lasted 6.5 hours. And then the other dot here is another cell phone that lasted 6.5 hours. Here, I've got several cell phones that lasted 3.5 hours. Those are all individual cell phones. So every single dot represents a cell phone. And the number that it's over represents its battery life. So a cell phone with a specific battery life. That's what each of those represent. One nice thing about a dot plot is that we can actually see all of our data points. They're all here, as little dots. So then one nice thing about a dot plot is that it shows each data point. Another nice thing about a dot plot is that I can pretty easily see frequencies. I can see how many phones had a battery life of 3 hours, how many phones had a battery life of 5 hours or 4.5 hours. And I can also pretty easily see the mode, right? It's going to be the tallest tower of dots. Here's where I had the most cell phones. So the mode battery life would be 5.5 hours. So that's nice. It's easy to see frequencies. And the mode. There are a couple disadvantages to dot plots. One, particularly if I have a lot of data, it could take a long time to make a dot plot. If I have 100 data points, that means I'm going to have to plot 100 dots. That could take a while. So it can be time consuming. To create. And then for our particular scenario, we were given the total number of cell phones. But if I wasn't given that in my problem, the only way to find it is to count up all the dots, okay? Which again could be tedious and time consuming. So you have to count all those dots to get your total. Questions for me on dot plots? Okay, let's talk about histograms. So I want you to notice for a histogram, we've got sort of a range that's included here. We know from our dot plot that we did battery lives in half-hour increments, right? 2.5 hours or 3 hours, 3.5 or 4. For our histogram, we go from 2 to 3, from 3 to 4 hours, from 4 hours to 5 hours. This sort of grouping that we create here is called a bin. Okay. So that's important to know. Each of these bars shows me how many cell phones fall into that bin, fall into that range that I've described. How many cell phones have the indicated battery life? The nice thing about a histogram is that, again, it's easy to see those frequencies, but I just have to keep in mind that I'm seeing frequencies for the grouping I've described, not necessarily a mode. So I couldn't say that the mode is 5 to 6, right? 5 to 6 includes 5 hours and 5.5 hours, right? But I can see some frequencies. And histograms also give us a good idea of the shape of our data. Where I've got a lot of data, where I've got maybe little bits of data. Okay, if I have a big cluster here and then a couple pieces of information over here, they're good for determining shape. And we'll talk more about shape next week. The big disadvantage to a histogram, though, is when I set up these bins, I have to remember that I'm no longer looking at exact values. Okay, I'm seeing groups. And if I've set those groups to be really big, I lose a lot of specificity. So we can't see exact values. Because our data is grouped. Questions on histograms? You guys have seen bar graphs since elementary school, so I know we're pretty familiar with how to read things that look like this, so these ones usually are not too bad. Now let's take a look at box plots. So box plots show us important information, but really different information than what we see in those dot plots or histograms. So for a box plot, this line down here at the bottom is over our minimum value. So if we remember, if we look at our dot plot here, the lowest battery life we had for any phone was 2.5 hours. So this bottom line of our box plot is over 2.5. That's our minimum value. So one thing we get from a box plot is our minimum value. The line farthest to the right shows us our maximum value. So if we look up at our dot plot, the longest battery life for any of our cell phones was 6.5 hours. So I have a line over 6.5. This guy here in the middle is our median value. So we also get our median from a box plot. And then these other two sides, the left and right sides of my box, are also important pieces of information. So the left side is what we call Q1, or the first quartile. What we're essentially doing when we create a box plot is taking our data and dividing it into fours. Okay, I divide it into 4 equal groups. I start by splitting it in half, and then I find the half of the bottom and the half of the top. It's like if you were gonna break a candy bar into fourths and you wanted to make sure they were as even as possible. So you cut it in half, and then you cut each of the halves in half. Okay, that's the big idea here. So this Q1 is the median of the lower half of our data. And then up here, the right edge of our box, called the third quartile, or Q3, and that's the median of the upper half of our data. The nice thing about a box plot is that it gives us what we call a 5-point summary of our data. So we know the minimum value, we know the maximum value, we know the middle of all of it, and then we divide it into 4. So there are 5 points. We get a 5-point summary of our data. A box plot is also generally an easy way to compare multiple data sets. So it makes it easy to compare 2 or more data sets. The disadvantage of a box plot is that aside from the minimum and the maximum, we're not getting any exact values. Remember, in some cases, when I go to find the median, I've got 2 numbers there, so I have to average them. So I can't count on this actually being a data value that I got. It may have been the average of 2 that were in the middle, and the same thing with my quartiles. My minimum and my maximum, I know, are actual data values that I had, but I can't be sure about the other 3. Okay, so I can't see the mode from here. I don't know anything about frequencies. I don't know a lot, I should say, about frequencies. So I don't have any of that exact information from a box plot. Questions for me so far? Okay, so for the rest of our examples for today, we're actually going to go through and create some of these. We're going to create a histogram. We're going to create a box plot. So if you would for me, please, turn to page 5. And up at the top, we have some data on tomato plants. So we're looking at how many days it took different tomato plants to actually have tomatoes on them. So that 47 we see means that I had a tomato plant that after 47 days of growing had tomatoes on it. I've got a couple 65s in there. That means I had a few plants that on day 65 of growing had tomatoes on them. That's what that means. So the first thing we're going to do is create a histogram out of this data. So let's take a look at what we've got. So what we want to do is, since we're making a histogram, if we're making a dot plot, I would leave all of these. I wouldn't do any grouping. But if we're going to make a histogram, I'm generally going to group some pieces of information together. Okay, so we're going to put them into, remember, what are called bins. Now, I want you to notice that there's actually a problem with my bins, the way that they're described right here. This number and this number are the same. The end of one bin is the same as the beginning of the next. I don't want that, because that means that if it took 50 days to have tomatoes on it, I could put it here or I could put it here. I don't want any ambiguity here, and I definitely don't want to be putting tomato plants in 2 categories. Okay, everybody needs to go in 1 category. So what I need to do here is actually make some adjustments. Instead of 40 to 50, I want this bin to go from 40 up to, but not including 50. If we had decimals here, this would be a little more complicated, but since these are all whole numbers, I'm just going to say instead of 50, we want 49. I'm going to make that adjustment for all of my bins. So instead of 60, I want 59. Instead of 70, I want 69. Instead of 80, I want 79. Instead of 90, I want 89. Instead of 100, I want 99. Now that we've got that adjustment made, what we're going to do is count up how many plants fit in each of these groups. So the nice thing here is that our data is already in order from least to greatest. That makes this a little bit easier on us. So I want in this first group, how many plants took between 40 and 49 days to have tomatoes? Well, that's just 1. And then 50 to 59, 1, 2, 3, 4, 4. 60 to 69, 1, 2, 3, 4, 5, 6, 7, 8, 9. 70 to 79, 1, 2, 3, 4, 5, 6, 7, 8, 9. 80 to 89, 1, 2, 3, 4, 5, 6. And 90 to 99, just 1. This is called a frequency table because it's a little table that tells us the frequency, right? Number of plants, how many, frequency is how many I have in each of these groups, in each bin. Now what we can do is take this information and create a bar graph, a histogram. So if I look at the bottom of my paper, I've got my axes all set up and labeled, how many days it took and how many plants that was. So for my first group, my first bin, 40 to 49, that's going to start at 40 and go up to 50, right? We cut off for that bin at 49. And I know that that was only one plant. So I want to make this bar 1 unit high. And now for my next bin, that was 50 to 59. That should be 4 units high. So I'm going to use a ruler here just so I can make it somewhat accurate. And then from 60 to 69 should be 9 units high. '70 to 79, also 9 units high. '80 to 89, I want that 6 units high. And then 90 to 99, I want that 1 unit. If you want to shade your bars, great. If not, great. Okay. What I care about is how tall they are, and if you have your bins, your bar width appropriate to your frequency table. Any questions for me on histograms? Okay. You guys have, again, done these before. These are not super new, so these shouldn't be too bad. So now let's take a look at a box plot. So if we're going to make a box plot, there are 5 pieces of information we need to pull out of our data. We need to know the minimum, that Q1 number, the median, Q3, and the maximum. So we're going to start by finding all of these for our data. That's what 1 through 3 is asking us to do. So we'll actually find those numbers first, and then we'll go back and talk about what they mean. So I'm going to line up another copy of our notes here, so that makes it a little bit easier to see our numbers and write them down at the same time. That way we don't have to flip back and forth. The first thing I want to fill in is that minimum. Again, since our data is in order, that makes it a little bit easier to see. It's going to be that first number, which is 47. And then our maximum we can pick out again pretty easily. That's our last number, which is 90. And now I want to find my median. I want to cut my data in half. Where's that middle point? So 1, 2, 3, 4, 5. 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And then we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. 1. 1. And then I've got 2 actually that are in the middle for this one. Remember, if I have 2 numbers in the middle, when I go to find the median, I take their average. I find out what's in the middle of those 2. So this would be 71 for our median. And if I put a line right here through my list of numbers, that cuts my data in half. I've got my lower half and my upper half. And now I want to find the median for the lower half. So where's the middle of my numbers from 47 to 70? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's another one, and I'm just looking for that middle. There's my Q1. There's the middle of my lower quartile, 62. The median for the bottom half of my data. And then I'm going to do the same thing for the upper half of my data. Let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. 1, 2. There it is. There's the middle of the upper half. So that's Q3. 78. So the median for the top half of my data is 78. Now let's take a look at what these things mean. So for number 1, it asked me to find the median, which we did. I want to know what the median actually represents, though, in the context of my problem. So we know the median is the middle, right? It's that middle value. So one thing I can say is that we'll say middle number of days it took a plant to grow tomatoes was 71. But because I know the middle, I know some other important information. What I know is that if that's exactly the center, then half of my plants grew faster than that. And the other half of my plants grew slower than that. So we'll say 50% of plants had tomatoes sooner, and 50% of plants had tomatoes, there we go, later. Number 2 asks me to find Q1. Remember, that's the middle, the median of our bottom half of our data. So this splits the fastest growing plants in half. So what I know is that of the fastest growing 50% of plants, half of them had tomatoes before day 62. So basically a quarter of my plants got tomatoes between 47 and 62 days. The other half of our fastest growing plants had tomatoes between 62 and 71 days. So the fastest quarter got tomatoes from day 47 to day 62. The next fastest quarter had tomatoes between day 62 and day 71. And then it didn't ask me to describe here, but for our third quartile, that means that the next fastest quarter of our plants had tomatoes between day 71 and 78. And the slowest growing quarter of our plants had tomatoes between day 78 and day 90. Does that make sense? Because again, the point of those quartiles is it splits our data up into 4. So now let's go ahead and actually turn this into a box plot, okay? So my minimum value is 47. So I want to find 47, should be right about here, and I'm going to put a line there. And then I need Q1, that's 62. So I'm going to find about where I think 62 should be. I'm going to put a line there. And then my median is at 71. So I think that'll be about there. So I'm going to put a line there. Q3 is at 78. So I'm going to go to where I think 78 would be. And I'll put a line there. And then my maximum is 90. So I'm going to go to 90 and put a line there. So I've got 5 lines here. The middle 3 make my box. And then I draw a segment out from the box to the minimum and the maximum. Now, I want you to notice that my box isn't split quite in half. This side of my box is just a little bit smaller than this side of my box. That's an indicator to me that I may have some repeat values in here, right? And we know that we had, I think, multiple like 75s, which would fall into this portion of my box, okay? Where this side of my box is more stretched out, that tells me I probably didn't have as many repeating values in there, okay? This tail, if you will, is a little bit longer than this tail. Again, that tells me I probably have more repeating values in this section. Okay? So I don't know what those individual values are, aside from the minimum and the maximum, but I have some general idea about what I should expect out of my data if I were to look at it. Questions for me on box plots? Okay. They're a little goofy, but they're not that hard to create. Okay. So for tonight, your homework is on page 7. I want you to look at problems 1, 2, and 3. There's a set of Khan Academy assignments listed down here at the bottom. Do not worry about those for tonight. Okay, just problems 1, 2, and 3. So it's asking you to pull some information out of a dot plot, create a box plot, and create a histogram. It gives you your bin width there. Okay, I want you to work on problems 1, 2, and 3 for homework tonight.